Good Wednesday afternoon, everybody. I'm meteorologist Tim Pandages, and here we are on the 1st of June, kicking off another Atlantic hurricane season. And the first tropical update for you, we're talking about remnants of what once was Hurricane Agatha in the eastern Pacific that made landfall in southern Mexico, that has now transitioned to a remnant low, and pieces of that are now getting absorbed into a broad circulation called the Central American Gyre. That's also spawning Invest 91L that could become Alex in the Atlantic Basin. So a lot to talk about as we go forward. First, before we get into what's happening now, let's talk about what the future may hold for our season in general. So NOAA, the National Hurricane Center, put out their outlook a couple weeks back calling for another above average, highly active season. 14 to 21 named storms is the forecast. Last year we had 21. The average, though, is 14. Now, of those 14 to 21, 6 to 10 could be hurricanes, 3 to 6 major hurricanes, Cat 3 or higher. So there are many reasons why we're looking at another above average season. A lot of it has to do with the setup in a completely different ocean in the Pacific. La Nina, the ENSO pattern. La Nina is cooler than average waters in the equatorial Pacific. That leads to a whole domino effect of a lack of wind shear. And the lack of wind shear means there's nothing to really keep in check storm development. Wind shear blows the tops off of storms and keeps them from developing or maturing. Without that, pretty much free reign. Sure, there are other factors, cooler ocean waters, dry air, things like that, but we've got very warm ocean waters out there as well, and that's leading to a 65% chance, according to NOAA, of an above normal season again. But we made it to June 1st this year without a named storm in the Atlantic Basin, and that is a break in the pattern. Since 2015, we've had a storm prior to June 1st. We haven't had one since 2014. So that breaks a 7-year streak of preseason storms out there. What does that tell us about our season? Nothing. All right, so in the tropics right now, the latest is Agatha's remnants now absorbed into the larger gyre circulation sitting over Central America. I'm going to show you that in a second. Now, a piece of energy that's right now been coined 91L has a high likelihood of developing into Alex. That would be the first named storm in the Atlantic Basin of 2022. Now, it could become a much stronger system, better organized, after it makes impacts or interacts with Florida, which is looking likely now. Until then, it's going to be a large, broad, disheveled system likely. And then once it moves over Florida, hits the East Coast, the Gulf Stream waters there'll be much more fuel and a much more conducive environment for it to maybe get a little more organized. So here's what's going on right now. We're looking at satellite imagery, and this goes back 36 hours. And I want you to see the remnants of what was Agatha move over Mexico, enter the southern Bay of Campeche. That's where the remnants are right now. Some of that energy, though, getting picked up by the larger Central American gyre that's sitting and spinning here over Central America. And that has transitioned into another lobe of energy, Invest 91L, that you can see is much larger in nature and also much stronger and getting stronger and more organized by the day. So again, we're looking at the Central American gyre here, and what that basically is just a large area of spin in the atmosphere sitting over Central America that at times can spin off lobes of energy that develop into tropical systems. That's actually what helped to develop Agatha when it was in the eastern Pacific, and then it's kind of still stuck in the same general overall circulation. So here's the latest from the National Hurricane Center. We're going off of the 1 p.m. advisory today. 70% chance of this developing within the next 48 hours. Within 5 days, that goes up to 80%, so highly likely. Right now, it's moving, just crawling to the north-northeast at 6 miles per hour, has winds of 30 miles per hour. To get a name, to become a tropical storm, you need winds sustained at 39 miles per hour. So we're not quite there yet, nor do we have really a defined center of circulation. Now, we're looking at the infrared satellite imagery here. What that is a filter on the satellite that depicts temperature temperature of the cloud tops. Now, why that's important, why we as scientists look at that, is because the colder the cloud tops, the more intense the convection or thunderstorm activity within a tropical system is. So when we're seeing the shades of black and the flare-ups of white, those are extremely cold cloud tops, meaning they're very vertically built and stronger in nature. So you're seeing this kind of play out over the last 5 hours. A flare-up of convection you see here, and then it kind of wanes over the last few hours. It's cycling. That's typical of developing tropical systems here, trying to get their act together. Now, I also want to show you what it looks like here on visible satellite imagery. You can certainly see the broad overall spin. Now, the Hurricane Center plots the center, potentially, of where this system is now. Northern Belize, south of Cozumel. There's Cozumel right there, so right along the coast of the Yucatan. When you're looking at this satellite imagery, you can certainly see the spin, probably likely more in this area here is where a center may be trying to form at the surface. And if it moves north-northeast and moves through the Straits of Yucatan, staying over open waters, very warm waters, this could potentially be a little bit stronger than what models are seeing. Now, here's our list for 2022. I already told you that if this does strengthen and get a name, it would be Alex. By the way, it's called Invest 91L now, if you're wondering what, in fact, that means. Invest, short for investigative. 91, it cycles from 90 to 99. It's just a number to keep track of things. And L tells us it's in the Atlantic Basin. Once it strengthens enough, it would get that name Alex, remember, 39 miles per hour or greater, to get a name and become a tropical storm. Now, in terms of when we normally see our first named storm in the Atlantic Basin, we're going off climatology now that's been updated from 1991 to 2020, so a 30-year average. Typically, the first named storm comes in around June 20th, so well ahead of schedule if it develops within the next couple of days. But also, the last couple of years, you know, as I just talked about, the first named storm came in well before June 1st, prior to the start of the season. So this is really going off of well before, say, 2015 or so, but it goes up until 2020. So typically, June 20th. So we're getting computer models coming in now. The spaghetti plots, each line is a different computer model. And some, if you can depict there, the yellows, all the yellow shaded lines, that's actually an ensemble model, the GFS. So that's the GFS model run, tweaked at initialization ever so slightly to get a different outcome. And that's why you see all these different runs there. But generally, you can see the trend is taking it to the north and then northeast towards the west coast, southwest coast of Florida by the time we get towards the weekend. Now, there are some inhibiting factors to this developing, and it's the wind shear. Remember what I talked about wind shear? It tilts the system over. Areas in green here are areas of high wind shear. That means winds aloft that are changing in speed and direction with height. This is generally moving into an area of higher wind shear. Do I think it's enough wind shear to stop this from developing? I don't think so. I don't think it's as strong as we would like to see to kind of destroy it. It's just not quite there. And on top of that, we do have very, very warm sea surface temperatures too to support the energy needed for it to develop. So let's talk about wind shear and tropical systems in general, why they're detrimental for them developing. A normal hurricane wind flow is a vertically built engine. From surface to aloft, it's built vertically. When you introduce wind shear into the overall development process, as those storms are developing vertically, the wind coming in aloft blows the tops off. So it cuts them off, suffocates the system from developing and ventilating properly. Talked about the sea surface temperatures. This is the anomalies, the departure from average. The yellows and oranges here throughout the entire Gulf of Mexico, the Caribbean, the Southwest Atlantic, all running well above average, 3 to 5 degrees above normal. Now, how does that correlate in terms of an actual temperature? Well, we're talking mid-80s already. And to get tropical development, you need 80-degree water temperature or warmer, and we definitely have that throughout the entirety of that potential storm track towards Southwest Florida. So here's how the computer models are seeing things. The European model shows a broad system, rather disheveled, not very organized, likely maybe a weak tropical system, tropical storm, moving towards Florida by Saturday morning with likely some rain and some wind. Now, the models do depict anywhere from 4 to 6 inches. Now, I do actually want to jump back and show you something else here, because the rest of the Gulf Coast doesn't look like they have anything to worry about here, because a big dome of high pressure is going to act as a block and keep that storm to the south, southeast of the Gulf Coast, with the exception of Florida likely getting impacted by the rain and the wind. Again, let's go over those rainfall totals, potentially anywhere from 3 to 6 inches. Certainly some higher totals thrown in there as well for Central and South Florida. Looks to be the spot that's going to see the highest impacts. All right, until next time, until this storm gets a name, which will be Alex, likely within the next 24 to 48 hours, we'll have updates for you on all our social media, on Twitter, on Instagram, and on Facebook. If you have any questions, feel free to reach out there. Until then, I'll see you next time.